In this short video, we're going to examine some of the multiple comparison procedures in SPSS. In previous videos, we've conducted analysis of variance. We've conducted the one-way analysis of variance. In class and in videos, we conducted them in two separate ways. One of the ways that we did it was through the general linear model. Another separate way we talked about it was under compare means. There's a one-way ANOVA option. We're going to go to the general linear model, go to univariates, and we are going to conduct an analysis of variance, but we're going to conduct it with the purposes of looking at some of the post hoc tests and contrasts that we can use as default here in SPSS. So for our fixed factor, we're going to put level of attractiveness in the fixed factor box, and our dependent measure is the number of statistics classes. We'll keep that. That's just how many labs someone attended. And previously, we had run this with some of our options, such as descriptive statistics, estimate of effect size, power. I won't go through all of the ones we've gone through previously, but I'm just going to select descriptive statistics so we can kind of see the means of our groups. I'll click continue. And I'll go ahead and click OK to get us started. And our default analysis pops up. We have our first between subject factors box, which we've looked at before. 8 people are participants in each of the groups. We have the means and standard deviations. We should also be able to see this in our Lomax text in chapter 2. We have some of those, the same exact means on page 61 of your textbook. We also have our F-test, which we've seen before as well, and we have a significant F result. And our question in class was, well, now that we have a significant result, what do we do? We're going to go over a couple of things that we could do in SPSS to examine the differences amongst levels of attractiveness as multiple comparison procedures and post hoc procedures. Under Analyze, we'll go back to the general linear model and univariate, and it kept our whole setup the same. We still have our dependent variables and our fixed factors the same. I'm going to go to contrast, and if you remember the difference between contrast and post hoc procedures, contrasts are things that I hypothesized ahead of time. Maybe there's certain structures in the data I want to observe. Post hoc comparisons are those after I have conducted the analysis and only after a statistically significant F value has been produced for our one-way analysis of variance, do I then examine some of the levels of means to see if they're significant or not. We're going to start with some of the contrasts, and in our class previously we have discussed some of the types of contrasts like trends analysis that we could do, orthogonal contrast, simple contrast. I'm just going to do a few of the ones that are default here in SPSS. They set up the contrast coding for you by default, so you don't even have to worry about that for now, although you'd be able to follow along with some of what we did in class. So if we were going to start off with one of the procedures we did in class, which was our trends analysis, we would look under the polynomial analysis here. We could select under contrast polynomial, select change, and now you see in the underneath factors you see group and it says polynomial. I'm going to go ahead and click continue. And I'll go ahead and click OK. We get the same introductory pieces of our descriptive statistics and our F value, but now we have contrasts of linear, quadratic, and cubic. And if you remember from class, we could only get J minus 1 number of contrasts, and also that for trend contrasts, as well as orthogonal contrast. So if we have 4 different groups, we're only going to be able to do 3 different types, levels of polynomial contrast. But also, in most cases, individuals don't test beyond the cubic contrast. So here we get a linear, a quadratic, and cubic contrast, and we can kind of jump to the significance level. We see significance for the linear. It is significance at 0.00. It is not significant for the quadratic or the cubic. which if we kind of go back to our textbook and look on page 61, we can see that we conducted these in a given our contrast coding, and which ones were significant and not. And we could also, to see the actual t-value, one thing I sometimes do, I could cut this, I could copy this and open up Excel, and paste this right into Excel. And I could just go through and say, well, this is the contrast estimate, which is the difference between, for the contrast, this is basically the numerator of our contrast. So I could take that numerator, divide it by the standard error, which is right here, and I end up with a value of 4.43. We could do that for each one of those contrasts, the same as we did on page 61 in the textbook, or even some of the practice work we did in class. This is just so that you can see, you can derive the exact same value with contrast coding and trend coding in SPSS. So we see that there's a linear effect according to our contrast coding. That's sort of the easy way of doing a contrast code in SPSS. We also get just a quick little table here. You don't have to really worry about this so much. It's redundant. As with the previous F value here, we see of 6.81, and now here we see the F value of 6.81. So we know that we have a linear effect in the model. Well, we also could have, and did before, under general linear model, under univariate, we could plot this, and we'll just take groups, univariate profile plots, put it on the horizontal axis, click Add, click Continue. Under Options, I'm going to take off the descriptives options just because I don't want it to kind of keep reproducing each time. Click Continue and click OK. And we get the estimate of the marginal means. These are the means effectively plotted. And we can see that these marginal means kind of tell us a story that there is pretty much a linear trend going on here, that attractiveness through very attractive has a linear trend. But we also have to remember that we have to have some sort of belief in that to have this type of analysis, and that belief is that there is some sort of continuous measure from unattractiveness through very attractiveness. So this is sort of the easy way I think of doing a trend analysis in SPSS. Other types of analyses that are default for multiple comparison procedures for our contrast. Under univariate, I'm going to go back to contrast. We can see that there's all sorts of ones here. We have several that are default, others that we could do with some hard coding, but for now we'll just do a couple more of the defaults. One of the ones I want to do is a simple contrast. And it gives us an option under reference category of first or last. I'm going to select first here and click Change. And you notice up in the box, it's going to have the factors by group, simple, and first. Well, in class we talked about having a reference group or a comparison group. And the type of analysis for contrast this is going to do is not an orthogonal contrast, but it's going to have a comparison group of the first category, the first group, in this case unattractive, versus all the other three. So we'll see how that looks. And what I'll do as well, under post hoc analysis, I'm going to go ahead and select the Dene test and click first as my control category so that we can compare the results of both the comparison as well as the post hoc test, because effectively these should do the same thing. I'll go ahead and click OK. And we see we now did a contrast. So basically our contrast code would say we're comparing group 1 versus group 2. So it might be a +1 for group 1 and a -1 for group 2 and zeroing out group 3 and 4. Then we're doing 1 versus 3 here. See that 3 versus 1 written backwards. Then we could have a +1 for group 3 and a -1 for group, or +1 for group 1 and a -1 for group 3, and same thing with group 4. So that could be how you might do the contrast coding, and we talked about that in class. But here we just default, did contrast coding, asked for simple. Now we're comparing 1 versus 2, 1 versus 3, and groups 1 versus 4. We can see that we have a significant result here of 0.033 for 1 versus 3. We have a significant result here of 1 versus 1 versus 2 is significant, 1 versus 3 is significant at 0.005, and 1 versus 4 is significant. Now I did the Dene test as well, and the reason why is under our multiple comparison procedures. We can see that as a baseline under the Dene test, see for a two-sided test, it does the same thing. It does unattractive is our baseline group, and then it compares it to the 3 other groups. Here, though, we see that there's a different significance level. This is actually, and the reason why is because it's a slightly different test. The Dene test has a different way of modifying for significance than our contrast. We talked a little bit about this in class, and this would be a little bit more in this perspective, a little bit more of a conservative measure. Now, I say it's a conservative measure, but what I really mean is that they're using different types of ways of controlling for family-wise error, and the Dene method is a family-wise method for multiple comparison, and it controls based on planned family-wise. Here with the contrast, we see that each one is tested independently. This will be thought out ahead of time as well. I think the better process is to simply use the Dene test. So we have several other methods for multiple comparisons we'll do. And what I'm going to do is go ahead and stop this video so that you can take these in chunks, go back and digest them. My advice is to hit pause and maybe practice these on your own. And I will come back from this point with another video and break it up into another 10 to 15 minute chunk.